So hi everyone, we are from group 3. We are going to talk about particulate matter detector. So let's roll! And this is my group member, me myself, Carolina Suzin, Farah Sadia binti Halim Sadi, Nuramira binti Muhammad, and also the last one is Muhammad bin Abdul Malik. About particulate matter, which is also known as PM, it refers to a tiny solid particle suspended in the air originating from sources such as vehicles emission and industrial processes, construction activities, and natural events like dust, storm, and wildfire. Inhalation of PM can lead to respiratory and cardiovascular issues, including asthma, bronchitis, and heart disease. Environmentally, PM can alter the Earth's radiative balance and damage ecosystem by depositing on soil and water. PM is measured using optical scattering, where a light source, or which known as laser or LED, passes through the air sample particles scattered on the light, and a photodetector measures the scattered light intensity. The scattered light intensity correlates to particles concentration, which providing real-time air quality data. So next we move to the history of particulate matter of monitoring dates back to the ancient time with significant pollution increases during the Industrial Revolution and major events like on the London smog in 1952, which per air quality regulations, technology advances in the 1980s introduced optical scattering principles for PM detectors, and in the 1990s saw improved sensitivity with laser-based technology. Since the 2000 real-time PM monitoring has integrated with smart city infrastructure, and affordable, portable sensors have made personal and indoor air quality monitoring feasible. So today, we can see that global awareness and regulation of PM levels continue to grow with ongoing innovation, enhancing PM sensors capabilities for comprehensive air quality management.
Particulate matter detector is a device to detect and measure tiny particles in the air, providing us with important air quality information. There are many methods and principles to detect particulate matter. One common method is by light scattering. The working principles of light scattering is based on the interaction of optic and electricity. The sensor captures tiny particles in the air through sophisticated optical system and then conduct precise measurement electrically. Particle sensor use the optical scattering principle to detect particles in the air. The sensor contains a light source such as infrared LED and laser that emits a beam of light, and a receiver that measures the intensity of the beam after it is scattered by particles. Size and concentration of particles affect the scattering of light, so the intensity of scattered light can be measured to infer the concentration and size of particles. On the basis of optical measurement, electrical measurement is used to further improve the accuracy of the sensor. By directing the scattered light beam into electronic component, the sensor converts the optical signal into an electrical signal. This electrical signal changes as the concentration of particulate matter changes, and the sensor quantitatively assesses the concentration of particulate matter in the air by measuring changes in electrical signal. The electrical signal collected by the sensor are processed by the built-in microprocessor. The microprocessor uses a preset algorithm to convert the measured data into actual particle concentration value. So these data are finally presented to the user through the sensor output interface, such as digital display or wireless communication module. Next is the gravimetric analysis. Gravimetric analysis of particulate matter collected via filtration is the most widely used technique for determining ambient concentration of particulate matter as well as the amount of particulate matter in emission. Gravimetric method takes in the ambient air for 24 hours at constant flow rate through a size-selective inlet that only allows particulate matter with an aerodynamic diameter of 2.5 micrometer or less to pass through. The samples of particulate matter are collected on the filter paper. The filter was collected onto a pre-weighed filter conditioned at constant temperature and humidity condition. The filter is then conditioned again under the same temperature humidity condition and reweighed. The difference in the weight corresponds to the mass collected on the filter, which along with known flow rate, sampling period and the total volume of the air sample is used to calculate the PM2.5 concentration. Gravimetric methods are based on calculating particle mass from the difference in weight between the samples taken before and after a sampling period. Typical gravimetric filters are made from glass fiber. The surface is covered by an intercoating layer such as polytetrafluoroethylene, which serves as protection from the chemical reaction. Condensation particle counter works similar to optical particle counter. The difference is that they can count particles which are much smaller than those counted by the OPS. Condensation particle counter condense a solvent such as butanol, isopropyl alcohol, and more recently water onto the surface of particles that cause the particles to grow to a size where they can pass through a laser beam of CPC and be counted. There are three types of CPC classified by the method used for growing the particles. So first, utilize expansion of the aerosol vapor mixture. Second type, utilize the conductive cooling. And the third type, utilize the mixing of cool and warm saturated air. Beta attenuation monitor principle measure the particle mass density using beta radiation attenuation. The particulates in the ambient air drawn into the particulate matter 2.5 monitor are deposited on a paper band filter and exposed to beta rays. Here, the electrons with energy in the range of 0.01 to 0.1 will get attenuated as a function of the particulate mass. As a result, the beta count reduced with an increase in the particulate matter 2.5 mass and is recorded by the detector and converted to concentration. Separate element oscillating microbalance determine the PM2.5 concentration by continuously weigh the particulates deposited on the filter attached to a hollow tempered element that oscillate in an applied electric field. The oscillating frequency decreases with the accumulation of particulates on the filter. As a result, thermal mass flow controller constantly control and measure the flow rate of the particulate matter 2.5 monitor, which along with the mass concentration, temperature and the other factor that is used to continuously calculate the particulate matter 2.5 concentration. So among all of the methods to detect particulate matter, light scattering and gravimetric analysis are usually used in the detector.
So for the result part, I will discuss about the particular matter and I will compare what is the difference between PM10, PM2.5 and PM1. So based on the introduction, particulate matter are a sensor that are measure the amount of small particles that are floating in the air by providing visual data on the air quality. So generally, there are three types of particulate matter, which is PM10, PM2.5 and PM1, which this PM indicates the particles width and aerodynamic diameter of end particles. So the concept behind this particulate matter are when the surface of the particle increase, it will significantly the diameter will decrease, which leads to smaller particles to have a large surface area per mass. So this will affect the behavior and also the interaction in the atmosphere. When comparing the particle matters 10, 2.5 and also 1, there are a few elements that I want to discuss. So the first one is aerodynamic diameter. So basically based on the particular matter, there are three, which is for the PM10 is smaller than 10 micrometer. So for PM2.5 is smaller than 2.5 micrometer and for PM1 is smaller than 1 micrometer in terms of diameter. So for the sources for PM10 is basically from dust, pollen and also mold spore, and for PM2.5 is combustion process whereby the vehicle emission and also industrial activities, and for PM1 is combustion related emissions such as like vehicle exhaust and also industrial processes. For the behavior in the atmosphere, there are for the PM10 is the coarse particles which can be settled relatively quickly due to their larger size. For PM2.5 is fine particles which will remain suspended in air for a longer period and travel greater distance. And for PM1 is ultrafine particles which contain high surface area to mass ratio. So this PM1 will stay suspended in the air for extended period and penetrate deeply in their respiratory system. For the health effect, for PM10 is cause respiratory issue and health problems upon inhalation. For PM2.5, it will possess greater health risk due to its ability to penetrate deep into the lungs and also bloodstream. For PM1 is basically ultrafine particles which can causes include cardiovascular disease, respiratory issue, and also systematic inflammation. For regulatory consideration for PM10 and then PM2.5, both of it are regulated by air quality. For PM1 is particularly ultrafine particles. So for the next result, I will want to compare how does LCS and also TOM work. So LCS is stand for low cost sensor, which is used to estimate the PM level. That includes the three elements that I mentioned before, using optical sensor and also other technology, and also tapered element oscillation microbalance, which is TOM. So this TOM will measure the ambitious particulate matter concentration in real time, whereby it will provide more accurate, also precise measurement of PM level. So as you can see in figure 1, the comparison of PM concentration from LCS and TOM. There are a few comparisons that can be seen from the figure. So for PM10 comparison, the study compared measured by LCS and also TOM. So basically, it shows that LCS are generally recorded lower PM10 level compared to TOM. But this is a show that these are different or not significant in most cases, since there are two are in different kinds of techniques. So this indicates that LCN and TMO measurement are reasonable agreement overall, since both of them have their own sensitivity and also accuracy. So for PM2.5 comparison, LCM also provide lower 2.5 PM measurement compared to TOM, but the difference are not statistically significant. So it was concluded that LCM are able to estimate 2.5 level effectively compared to TOM, since there is no difference statistically significant. So for PM 1.0 comparison, it was reported also that LCS have a lower PM 1.0 value compared to TOM, which is despite the variation in absolute values, LCM are effectively estimate PM 1.0 concentration, show that reasonable agreement with TOM measurement.
For the PM10 irritates human airways, especially among asthmatics and the elderly. These particles make your eyes burn and your throat dry. Public health experts, however, are less concerned about these larger forms of particulate matter because our body defenses are responsibly effective against them. Tiny hairs along the respiratory tract block a portion of PM10. You cough and sneeze some of it out, and the throat mucous elevator transport a fair amount back out of your mouth or harmless into your digestive tract. For the PM2.5, the human body struggles to effectively block PM2.5 because these tiny particles can evade the body respiratory defenses and infiltrate the lungs and even the bloodstream. This infiltration can lead to various health issues. Studies indicate that a mere 10 mg per meter cubic increase in PM2.5 in the air raises the likelihood of death from the heart disease by 10%. Exposure to PM2.5 can result in increased incidence of bronchitis, reduced lung function, asthma attacks, and premature death. It is estimated that PM2.5 causes approximately 4.2 million deaths globally each year. Essentially, in the realm of air pollution, the size of particles is a critical factor. For PM1, in 2020, a study conducted in 65 Chinese cities revealed that for every 10 microgram per meter cubic increase in PM1 levels, there was a 0.29% rise in the risk of heart disease for individuals. The study highlighted that this impact was more pronounced for PM1 compared to both PM2.5 and PM10, given the average PM1 levels of 27 microgram meter cubic across the 65 cities. Another study published in the journal Hypertension in 2020 explored the potential correlation between PM1 and high blood pressure. This study focused on examining nearly 10,000 Chinese children aged 5 to 17 during the period of 2012 to 2013. The study found that almost half of the children were frequently exposed to the tobacco smoke, and around 10% resided in the household that used coal for indoor heating. The diffusion size classifier can estimate particle number. PM is charged in a unipolar diffusion charger. Then it passes through two electrometer stages. The first stage or diffusion stage consists of a stack of stainless steel screen connected to sensitive electrometer. And the second stage is HEPA filter connected to an electrometer. The position of particles in each of these areas generates a current from which it is possible to calculate particle number and the average diameter of the particle. One advantage of the disk is that it is small, portable, and cheaper than CPCs, which makes it suitable for implementing into embedded system. The drawbacks is that there are certain circumstances in which the disk can perform poorly in terms of accuracy. Larger particles can carry more charge, which leads to overcounting.
And now we can see that a particulate matter detector uses optical scattering principles to measure the concentration of tiny airborne particles and are widely used for applications ranging from indoor air quality monitoring to industrial emission control. The data that they provide enables action to improve air quality and protect public health. As air quality concerns grow, this detector will become increasingly crucial in pollution management, and technological advancement will enhance their sensitivity, accuracy, and affordability. And integrating PM data with other environmental sensors and smart city infrastructure will enable more comprehensive air quality management solution in the future. So basically, these are the references that we use to do some research about particulate matter. And now we have reached at the end of the slide, and that's all from us. Thank you.